Bam! Mr. Taru. In this math lesson, we're going to be taking a look at the question 3 of the 2017 AP Calculus AB exam. It is going to be a 4-part question, and it's going to be involving net change theorem, intervals of increasing and decreasing, finding absolute minimum on a closed interval, and find some values of second derivatives or discuss why it does or does not exist. In the description, you'll find timestamps to jump ahead to a particular part of this question. You'll also find links to the apcentral.college board website where you can download a PDF of all these questions, a PDF of the marking schemes, and a PDF of the master graders' commentaries to explain where students earned the most and lost the most points to help you get a 5 on your exam. The function f is differentiable on the closed interval from -6 to 5 and satisfies the initial condition of f of -2 is equal to 7. The graph of f prime, the derivative of f, is on the right, and it consists of a a semicircle and a line, 3 line segments. Not every time, but a lot of times where they give you a closed interval in the directions of your question, that means you may be using intermediate value theorem, extreme value theorem, or mean value theorem in one of the parts of your question. Anytime they tell you that a function is differentiable, that also is going to be your justification to why that function is continuous on a particular interval. Again, that can be important for using some of these theorems, such as I mentioned. Make sure you check those conditions before using any of those theorems. And make sure you understand, they didn't change the notations on us on this one, and they like to do this with more and more with their modern exams, but if they use a couple of different function names, make sure you recognize that you realize that there's a relationship. Like if I said, I don't know, if there's some kind of notation and you see that, wow, okay, it looks like g of x is the derivative of f of x, make sure you make that footnote somewhere in your work. For here it says find the values of f of -6 and f of 5. And I say this all the time in my class. If you integrate a rate of change, which is what a first derivative is, at least it's a rate of change of f prime is a rate of change of f. If you integrate a rate of change, you get an amount of change. And that's exactly what's going on here. It's called the net change theorem. And we're going to use the fact that even though we don't know what the function is, all we have is a graph of the derivative, we're going to be finding the value of f. Given the fact that f of -2 is at 7, we're going to find the value of f at -6 and find the value of f at 5. So kind of like using the GPS on your phone. Hey, I want to go here. The first thing it's going to go or say or figure out is, where are you at? And then I'll tell you where you're going. Where are you at when x is -2? It's 7. You're going to use that fact to help you figure out where f is at -6. So f of -6 is going to be equal to, well, the only value that you know, which is f of -2, and then to that add the amount of change that you have from -2 to -6, the amount of change that you have between those values. Well, the amount of change is going to come from integrating that rate of change. So that's going to be equal to, so we're going to have f of -2 plus the definite integral from -2 to then where you're going, which is -6. And again, if you integrate a rate of change, you're going to get the amount of change between -2 and -6. Now, of course, there's a problem with the way that I've written this definite integral, and this isn't necessarily what needs to be your first line of work. It just works for me. Your lower limit on a definite integral needs to be the lower limit, and right now it is not. -6 is lower than -2, so we're just going to swap these limits, and that means we're going to change the sign, in this case positive to negative, of that definite integral. Awesome. And I'm not going to write equal signs next to every line of work, because I don't, if I make some silly, if I write something like I write a +6 here instead of, or +6 instead of a -6, I don't want the AP scores to be required, be forced to stop grading and say, oh, well, you said this is equal to this line, that's a linking error, we have to stop grading, which they have to do, and you wouldn't get any points, even if you drop the negative back in a successive line. So this is the next step. And now we're going to have f of -2 is equal to 7. and then minus. Now, we don't actually have a function to integrate and then plug in -2 and -6. No, this is also a question dealing with finding areas of common geometric regions, just recognizing that that's what we're being asked for with this definite integral, and definite integrals have many more applications than just, well, finding area. So from -6 to 2. From -6 to 2, we have a triangle that is above the x-axis, or has, we have a function given us positive y values. That's the area, or the definite integral, which is really just a limit of sums, is going to be positive. And the area of a triangle, of course, we know is 1/2 the base. All right, easy enough. 1, 2, 3, 4 times the height, and that height is equal to 2. So that's going to be equal to, well, the 2's cancel out. We got 7 minus 4, which is equal to 3. Well, it's just equal to 3. I was going to say 3 units, but that just therefore means that f of -6 is equal to 3. And that's half of our answer. Just make sure, I don't know, whatever, I don't make some careless mistake. Boom, perfect. Now, for the second part of this question, we have the fact that we're asked for f of 5. Well, the same thing, okay? You know a function's value at -2. Off of that, we're going to start integrating from -2, because in these, this lower limit of my definite integral is always going to match the independent variable that I've plugged into my function, 2, 5. What they're looking at in the first part of this question is to make sure you understand, or you set this up properly the way I'm doing it, that we're basically, when we change those limits on the definite integral, that we change the sign of the definite integral. Here we don't have that problem. -2 is lower than 5. So we have f of -2 is 7 plus, and from -2 to 5, I'm pausing. They don't do it here, but if you were actually going to need to integrate these functions, you would need 2 integrals. You would need an integral from -2 to +2, because you have some function defining the boundary of that area. Another integral between 2 and 3, because you would have this function defining the upper bound of that area, and another integral from 3 to 6. So if these were actual functions that we would have to integrate and work out the definite integrals, it would require 1, 2, 3 different integrals. But this is a common geometric region. We don't need to do that. So we have 1/2 for the semicircle, pi r squared, and the radius is equal to 2. But make sure you realize that this area that you're accumulating is below the x-axis, so this is going to be a negative value. And then plus the area of the triangle, which is 1/2 base of 3 times the height of 2. So we're looking at 7 plus one of these 2's is going to cancel out with one of these 2's. So we have -2 pi. So again, 2 divided by 2 is 1, and we have 3. So our final answer is -2 pi is equal to, I like to box in my answers. Hope that's not a bad habit for the AP test. I also like to, since I'm going to do all my scratch work without writing equal signs next to everything, because again, I want to avoid that linking error thing, when I get to my final answer, I like to just re-summarize that actually is equal to, well, what we're being asked to find. And that is perfectly fine. Okay, anything there? Yeah, not really. That's the end of part A of this question. Part B coming up right now. Part B, on what intervals is f increasing, and justify your answer. Okay, we have our function over here, and there is variations in textbooks that define when a function is increasing or decreasing. I can see from my notes that in the marking scheme they said that the intervals of increasing and decreasing are on a closed interval. you could very well be writing that as an open interval. Books kind of go back and forth on that. I would say look over the most current marking schemes that they offer on the website for the AP tests, and just use the proper notes. Just use the notation that they use. So my books I teach from talk about functions increasing on open intervals. They happen to identify closed ones. But at any rate, well, you have a graph of f prime. F prime is the derivative of f, and if your derivative is positive, well, then your function's increasing. So, and it does say, you shouldn't even be reading this, everything you put on the AP test should be justified, but it does say specifically justify your answers. So you're going to say that f prime is greater than 0 on the interval from -6 to 2. AP is constantly evolving. I've got videos for old AP statistics. Maybe some of my notation and statements in those old videos aren't quite in sync with what they're really looking for on those scoring guidelines now. This particular test uses interval notation for intervals. I've been noticing that on the most recent test that they're just actually writing statements like x is greater than or equal to -6 and less than 2. Either of these are interchangeable. I do generally focus on the interval notation because my textbooks I teach from do, but at any rate, little comment. F prime of 0 is, f prime is greater than 0 on the interval from -6 to 2 and from what? 2 to 3, 4, 5. That would be -2. And therefore, f is increasing on, and I'm going to use the notation that they use in this particular year's marking schemes, and thus is in my notes that I made for my class, but it's increasing on the interval from -6 to -2 and from 2 to 5. Double check here. Now, they tell us, and we know, that you cannot find a derivative at the endpoint of a closed interval. It has to be on the interval. We talk about functions being continuous on a closed interval and differentiable on an open interval, and differentiable means you're finding slope, and that means you can't find slope at the endpoint. So it really bothers me, and I really want to just say, hey, these are open intervals for the function to be increasing and decreasing, because how do you take a derivative at an endpoint? How do you find the slope at the end of a closed interval? Now, I also noticed on some of the more recent years of AP tests that they might take this kind of question and combine it with, where is f increasing and say concave down, where you have to understand that the behavior of the first derivative can also help you to determine the concavity of a function. And if your derivatives are decreasing, well, then your function's concave down. And if your derivatives are increasing, right? Well, if your functions are decreasing, if your derivative is decreasing, if f prime is decreasing, then f double prime, the slope of f prime, would be what? Negative. We always talk about if your f double prime of x is negative, then the function's concave down. Well, f double prime of negative means f prime is decreasing. So this would be an interval from -6 to -2, where f is both increasing because the first derivative is, or f prime is positive, and f is concave down because f prime, while positive, is decreasing. Of course, increasing and decreasing is not the same as positive and negative. So f is increasing and concave down on the interval from -6 to -2, for those reasons, f prime being positive and f prime being decreasing. So let's just be aware of that as we get ready for our AP tests in 2020 and beyond, as opposed to just looking at these older exams to help us review. Part C coming up right now. Part C, find the absolute minimum of f on the closed interval from -6 to 5. Told you, anytime they give you a closed interval, intermediate value, well, no, not every time, but intermediate value theorem, mean value theorem, don't forget there's two, one for integrals, one for derivatives, and intermediate value theorem is probably going to come into play. And It's not necessarily really a problem for this, but we can say that f is continuous since f is differentiable. We don't have to have a function which is continuous for there to be an absolute max or absolute min on a particular interval. Turns out that none of the parts require you to check this condition, but it's going to be standard on a lot of your AP FRQs. Find the absolute minimum of f. Oh, thank you, the air went off. On the closed interval from -6 to 5. Well, I'm glad I'm not sweating, but at the same time it's annoying for the hum in the background. Okay, let's not forget, my students have to be reminded this all the time, identifying a relative extrema requires things like saying for relative max, f prime changes from positive to negative, or for a relative max that we have maybe f prime of c is equal to 0 and f double prime of c would be less than 0. There's some conditions to check. But when you find an absolute extrema, all you have to do is test the function's value, boom, f, at the endpoints of the closed interval and at any of the critical values where f prime is equal to 0 or undefined. Well, we can see here that f prime equals 0 at x equals -2 and x equals +2. So we need to test the value of f of x at the x values of the endpoint, each of the endpoints, and at each of the critical values. Now here's another thing. If you go to that AP Central website and you look at all the PDFs of old exam questions and their scoring guidelines or marking schemes, there are some years where they test the function's value at every critical value, and there's some years where they just say, hey, we're only going to test where it makes sense. In other words, here my first derivative is changing from positive to negative, so there really is no way for there to be a relative, or excuse me, absolute minimum when this is a location of a relative maximum. That wouldn't make any sense. How could an absolute minimum occur where there is a relative maximum where f prime changes to from positive to negative, and therefore this is a location of a relative max? I say leave it out. I want to say leave it out to save you some time on your test, but there are years where and I can look at the marking scheme, and that's my notes which have matched, they include it. Anyway, so f of -6, we already figured that out. F of -6 from part A was equal to 3. F of 5 from part A was 10 minus 2 pi, and now f of 2, this one they didn't ask us to find ahead of time, f of 2 is going to be equal to f of -2 plus a definite integral from -2 to 2 of f prime of x dx. So that net change theorem again. So we have 7 plus, and again that common geometric region, negative, because these y values are below the x-axis, giving us a limit of sums which is a negative value, -1/2, because it's a half circle, pi r squared. So we're looking at 7 minus 2 pi. I'm saying to skip it. We know f of -2 is equal to 7. That's actually given to us. So which of these is the what? Absolute minimum value. Well, that's positive. That's gone. That's, well, these maybe will be positive as well. They are all positive, but we have 3, we have 7, we've got 7 minus 6.28 basically, and we have 10 minus 6.28. So therefore, we have an absolute, well, what we have is we have no space. There's an absolute min. F has an absolute min. Chalk down! Minimum value of 7 minus 2 pi at x equals 2. Now, maybe not everywhere f exists, but on that closed interval, negative 6 to 5. And that is, what are we on? Part C. Part D coming up. Well, of course, right now. No. Number 3, Part D. For each of these values, f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. Okay. So we're being asked to find the slope, the second derivative, of f prime, the first derivative. Okay, well, let's see here. We've got f double prime of negative 5 is equal to 1, 2, 3, 4, 5. We're looking at basically, we're in the middle of a line segment. We know how to find the slope of a line. It's rise over run. It's down 2 over 1, 2, 3, 4. So it's down 2 over 4, or negative 1/2. Okay, not too bad. Now, what about double prime of 3? What's that equal to? I want the slope of f prime right there. Well, it's a sharp bend. Doesn't exist. Yay! No, not yay. I didn't write it, but the problem does say, and basically, again, don't ever assume that you can't or don't need to justify your answer. Why is this the answer? Well, and actually, as I glance down, I do see that maybe just to make sure we're completely thorough with our work, even though myself, it's like, yeah, I can see that, but rise over run, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's make sure we show all of our work. Got to justify it. And saying that you cannot take a derivative at a sharp bend doesn't fly. I think a long time ago it did, but now they're going to want to say, okay, hey, basically what you want to figure out is what's the limit as x approaches 3 of f of x minus f of 3, well, f prime, we're not finding the slope of a function, but the slope of the derivative, over x minus 3. Right? That's your, well, as my textbook calls it, the alternative form for the definition of a derivative. Book I have been teaching out of for years makes this almost like a footnote. My new book I'm going to be teaching out of next year does a ton of problems with this, and a lot of times is actually quite easier than the standard definition, as I'm learning through my years of experience. You still need to show that and justify why the answer to this does not exist. And what you're going to do is remember that we're finding a two-sided limit. And to have a two-sided limit that exists, that means that the left-handed and the right-handed limits have to be equal. And that's exactly how you're going to justify your work, that, well, it doesn't exist. So how do we arrive at this answer? We say that the limit as x approaches, and this is equal to f double prime of 3, the limit as x approaches 3 from the left of f of x minus f of 3 over x minus 3, seeing that this is an alternative form for a definition of a derivative, you can just simply then look to the left and say, well, that derivative, that slope, is equal to 2. And the limit as x approaches 3 from the right of f of x minus f of 3 over x minus 3, again, not necessarily have to do any work, just recognize that this is the definition of a derivative, the alternative form for the definition of a derivative. To the right of 3, we have a slope which is equal to negative 1. Well, and I want to kind of read backwards here, but the limit as x approaches 3 from the left of f of x minus f of 3 over x minus 3, does not equal the limit as x approaches 3 from the right, and therefore the limit as x approaches 3 of the same expression does not exist, and therefore f double prime of 3 does not exist. And just want to make sure I didn't leave anything out. That is it. And that is the end of our last example and the end of number 3 for 2017 Calculus AB exam. I'm Mr. True. Bam! Go do your homework.